Good evening to all. I'd like to thank you all for being here this evening. Notice of a workshop, June 7th, 2017. Notice is hereby given of a workshop of the Board of Directors of the District to be held at 1054 Road, Port Isabel, Texas, on the 7th day of June 2017 at the hour of 5:30 p.m. for consideration of the business of the agenda below. This notice is posted at the office of the District June 1st, 2017. 9:25 a.m. in accordance with the Texas Open Meetings Act, Texas Government Code 551-041, 551-050, and copy furnished to the county clerk in Cameron County. We do have the presence of a quorum. All the board members are present. Let me please have everyone stand for the pledge of allegiance.
Allegiance to the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Charles?
Heavenly Father, Jesus Christ, thank you for having this water district and allowing us to continue to meet the facilities and demands of the citizens, and just help us continue to have that right planning to develop the right capital projects and continue meeting the needs and health and safety of our employees in the district. And I say these things in the name of Jesus Christ, amen.
Amen.
Yeah, I know, right?
Item 3, consider and discuss unfunded capital improvement projects as follows. Flood holding tank at Port Isabel water treatment plant, use of Wampa wastewater treatment plant, grit removal and hydraulic improvement, Amy Bowie wastewater treatment plant, grit removal and energy efficiency improvement, lift station rehabilitation and enforcement upgrades, and water treatment facility.
Yeah, it'll just be in the PDF file.
And new sludge drying bases at water plant number 2.
Yes, good evening. I just want to mention that I know that the bonds takes a lot of procedures, and this is one of the first steps that we need to move forward on, at least advising the board what the needs are for the water district. Not necessarily that the board will approve everything that we need, but it's best if, look at every option that we have and make sure that if you don't understand something, just ask right away, stop us and ask questions, because I know that I don't know everything, but we'll get to the answer sooner or later. And something that's not mentioned to you guys, we need to go ahead and if you all think of something, let us know. But there is a lot of procedures to it from the beginning to the end, and at the very end, it's the voters that have the last choice, to vote for it or not. But right now, it's just a start, and like I said, not all of us know everything that goes into it. We have bond counsel that advises us on steps, and then we have our financial advisors also to go ahead and advise on the funding for it, the percentages and all that we need. But it's going to take, that's why we started early. Charles had mentioned to me, these are all the needs. And I know that he likes to spend the money wisely, making sure that we have all the capital improvements, going, get them fixed. Because I know that we've been finding more stuff as we go along. And meaning that we're not too sure if by the time we end all this, these payments and bonds and everything that's included, that something else is going to break sooner or later. That's future stuff. But at least right now we have identified a lot of the issues that we have, infrastructure that needs to be corrected and taken care of. There is room for improvement on the bond finance, the tax increments that we have now and what we had before. So Charles has mostly the full report. One thing that we had mentioned is on the existing 2012 Proposition 2, it's still pending. We got advice, just to hold off on that one. You can't really go to the voters and request something and then do away with something else that they approved already. So I believe that that one is going to have to stay there until, falls off. Yeah. time will take care of that one.
Who advised that?
The bond council, the bond council,
Was that Proposition 2, was that the, seawater treatment?
seawater desalination plant, correct,
Desalination.
right, right.
So,
So,
it can't be.
no, it can, but the best,
Extended?
it can be, but the thing is that he advises to, yes,
So
just
that's a,
leave it there.
you've been given advice, you reported to us that may not be wise,
Right.
but
Correct.
that's still something to be considered and discussed, for me to
Right.
fully understand.
Okay, yes.
So we're gonna go, my simple thought is, we're gonna go to the voter and say, we need another bond.
Mhm.
If we go back and say, okay, this is not feasible for these reasons. and
Correct.
it's interest in the district, we would like to,
And that's one of the proposals, one,
can you reassign it, or?
right, no, one of the recommendations is that you let the voters know that you're just gonna not move on it because of the reasons that we have. There's a lot of reasons. One of them is, it's not feasible to do it now, costly, and then operations on it, it's expensive. And then, the cost of,
It's honesty with the people,
correct,
the voters.
right,
And my simple thought is, if we're gonna say goodbye to sell a new bond for more money, that would translate to money from the taxpayers, that
Right.
we consider rescinding, or whatever the term would be, or
correct,
getting away from that at the same time, which is open dialogue.
right. So that, yeah, that could be a possibility, but as of right now, we'd like to keep it there and leave it alone, you know, not mess with it, but at least advise, the voters that, we're not gonna touch it because it's not feasible right now, not cost effective.
Maybe there could be a resolution passed by this board saying at this time, we don't foresee us fulfilling that
Need-
proposition
Yeah,
two.
right,
Yeah, and we'll need bond counsel, because that's a gray area that we'll have to address.
right, so we'll keep getting it, but we'll get more information as, we go along.
Summarization of what our current obligations are, term and lengths,
Right,
all the way down, and if there's a way clean, refinance some of those, and where we're going, and what we want to do, what our financial advisory council says, our bonding capabilities are revenue and,
tax,
tax laws.
right. But, yes, as we,
What our max are, what we're trying to do, because you can bond and borrow money, and it's limitless, these projects. I mean, the list would keep going, and you never have to.
Right.
Right. I've learned that,
right. So as we go along, we'll present more stuff, and do's and don'ts and, pros and cons and all that good stuff. But, right now, what we have is that list of the needs, so I'll let Charles take over.
If we can just scroll the next page on the PDF file.
Just speak loud, Charles.
All right.
Can I make a suggestion if Charles could come up here?
Yeah,
That'd be
sure.
great.
That'll work. Yeah, because, I mean, this is,
We're all getting a little older up here.
yeah, now, I think you should talk at the podium, thanks everybody. But I mean, this is a list that I think has been in prior, board meetings and presented. And really, at this point, we don't know what that actual cost is gonna be, where we're still trying to determine that need, and we wanna have that final cost known by the first August meeting? Oh, sure. All right, so at this point, our first project we're presenting for consideration onto the bond is the sludge holding tanks at Port Isabel wastewater plant. And it has an estimate of $2.2 million, with the design already being under contract to be completed by Corollo through their existing amendment. So we can finish it out and have it on the shelf until funding allows us to proceed with bidding. That's basically where it sits right now. And, yeah.
My thinking and conversation for more than that, I have a little concern about this. Finishing and spending the money and let it sit on the shelf if we want it. With changes in technology, changes going on in the world, is that the wisest thing to do?
Yeah, it's tied to really the diffusers and the aeration equipment we're putting in today. I mean, the fact that we're changing from Corsair to Fine Air, that,
How much sludge holding
Oh, the sludge holding tank, we're not dealing with an innovative technology that would change. We're just dealing with something that we should have always had and we're trying to get, basically. I mean, like as far as the purpose of these holding tanks. Well, I mean, they're already at 75% complete. I mean, it's part of that. There's only, I mean, the amount remaining in that amendment that was approved back in January. Yeah. Mhm. Yeah. I mean. Yeah, and actually, I just spoke to Corollo, where they haven't released. I mean, really, it's kind of electrical.
Did they finish out the plant yet?
And they haven't been released yet. Well, I mean, which is actually half being their subcontractor. And I mean, it's really just basically we're kind of waiting on giving them the green light from the design side, but from the construction side with CSA, they've already released the equipment to put in fine air diffusers in basins 2 and 3. And so. Right. Yeah. For sludge holding tanks, basically, there's 4 basins out there. Yeah.
I remember all that.
Okay.
And I remember clearly that we said that it's not a consensus of the board that sludge holding tanks are really practical or feasible at this time. So I'm just asking why we're continuing on with sludge holding tanks.
Well,
Mr. Chairman, I think we're kind of out of order here on what we're doing. He's just going over this right now. And he's going to, then Charles is going to be going over this right now. And then I believe Garver and Richard are going to be talking about that. The sludge holding tanks are in this.
Right.
So let's just wait till we get to here before we start getting into the specifics on this.
Yeah.
Is that fine?
Yeah, no,
Okay. Yeah, so this is just an overview of what's part of the presentation for justification that we dive into, knowing that we have a completed feasibility report for water reclamation, so those costs are known. We have a completed preliminary report for the nude sludge basins at Water Plant 2, so we know that cost, and we have a good handle on the construction cost for sludge holding tank. And really, the grit removal at the island and the energy efficiency annually and our lift station rehab really needs a lot of work. So we can identify those needs, which is part of what this bond application report is going to produce. And so I guess if we just move on to the next page, really.
Hold on, Charles.
Yeah. Oh, yeah.
On this first page here, it would have been nice to have a total, so I added it up. So if we decide to do the reclamation and if we do get a $2 million influx from the Title 16, I guess?
Yeah, I gave you a
So this totals up to $9.6 million with the unknowns items 2, 3, and 4. Is that correct?
Yes.
Okay. All right. Thank you. Correct.
Yes. And this is just an update of our 5-year CIP. You know, a lot of the stuff can get covered through our infrastructure, like our water infrastructure and sewer infrastructure, through our revenue that we're already, setting that money aside. So really, we are considering our capital needs as a whole and just pulling the projects that would be applicable to the bond election for this effort. And so we can go back and reference this as needed for a full detail, but I mean, at this point, we can really just dive into the Garver presentation if you're okay with it. Yeah, I guess hand over to Ricky.
All righty. Good evening, Mr. Chairman, members of the board. Richard Correa with Garver for the record. Can I control this from here?
Oh, yeah, they do.
Okay. Gotcha. Okay. Well, thanks for having us again. Just a quick overview. We hope to provide some explanation for some of the tasks that we're going to be doing, the projects that are on your list as unfunded projects, and hopefully answer any questions that y'all may have. Next one. This is the agenda. So just a quick overview. These projects are generated by your 5-year CIP from 2017 to 2022. It's part of the capital improvements project list that Charles just went over, dated June 1st, 2017. Projects are also supported by previous reports that have been completed by others in the past, and these projects are supported by the state water plan as recommended water management strategies. So again, just to go over the bond program overview, and I think I just went over most of those, but you've identified these needs, you've refined the list, and you've got reports that have already provided recommendations on what mitigation strategy should be, and construction alternatives. And what we're hoping to do is develop the report that's needed for the November 2017 bond election. We got to have that in by August 9th of this year. Garver is currently tasked with the preparation of this report from the last board meeting. Just to go over this again, developing the report, documenting all of the drivers, getting the accurate costs in of what these projects are going to run, and the deliverables are the draft report, having a July 2017 workshop to review the draft report with y'all, and then delivering a final bond report that'll be submitted. And this is one of, hopefully, the results of the report will be outlined in this format so that that can be laid out in CIP format. And one of the other things we're going to do on the next slide is develop these handy one-sheet summaries per project. That way you don't have to dig through the report on page 326. Section A, you can just go through and look at all of the project details.
Question, Chairman? Yeah, well, going back to the previous one with the bar graphs, that's the estimated cost on what we'll need for each of those years. Is that correct?
Well,
Like in 2018, we're gonna need what, $3 million? In 2019, we're gonna need $4 million? Is that?
This is a sample of the format only. So we took what was originally, yes, sir.
Okay.
We took what was originally 16 million as identified in projects, and we just kind of spread that out to show what kind of format you could anticipate.
Okay.
Yes, sir. Absolutely.
Thank you.
All right. So sludge holding tanks. Just a quick recap. Excuse me. Sludge holding tanks were previously analyzed. There are TCEQ compliance drivers associated with implementing sludge holding tanks, operation and maintenance drivers, solids loading and handling drivers, and then of course redundancy drivers, and I'll go into detail on the next slide. So you've already paid for an evaluation and an analysis to determine that these are needed. That's the first driver. The second driver, and probably most important, is that since you're switching to fine bubble aeration, you have to have a sludge holding tank, and one sludge holding tank will provide this compliance. As the slide indicates, conversely, the absence of a sludge holding tank would be a non-TCEQ compliant operation. Operation sorry?
All right, so I'm still unclear on when you say absence of a sludge holding tank is non-TCEQ compliant. Well, we don't have one now, so that means we're non-compliant?
Well, the non-compliance isn't triggered until the fine bubble diffusers are installed. Because with Corsair, you don't have to be taken offline, but for Pioneer, the diffusers that are going to be sitting at the bottom of the tank, so you have to have the ability to take that thing offline for maintenance. And if bases 2 and 3 things are digesters, we're not going to have that volume to be able to take anything offline when there's going to be full. And really that's...
The way we're going now.
Right.
The way we're going to...
Yeah, today, the problem we've always had at Porterville is we can't take anything offline because we have no space to send it during maintenance periods. Like the volume is just full.
And so what we're doing now with the rehab, without the sludge holding tanks, we still cannot take things offline, is that correct?
Well, the plans were bid, well, basically the sludge holding tank is a big package that's entirely separate.
Well, yeah, I'm saying the way we've done it so far is we haven't done the sludge holding tanks.
Right, like
Okay.
right now, we're building one air supply system and 4 tanks for aeration equipment. And that, all that aeration equipment is fine bubble diffusers that need to be maintained. Have to take them offline once a year and clean out all the sludge and that effort.
And can we do that?
Well, yeah.
Without a sludge holding tank?
Well, we can do that, yes. But the thing is, for us to do that, we'll have no digester basically when we're doing maintenance on the aeration. And that's where we run into this trouble where the sludge holding tank would get us through the maintenance period.
Got it.
Explain it.
Okay.
So we're switching from coarse bubbles to fine bubbles,
Yeah, like a sludge holding tank,
getting ourselves into a non-compliant situation.
well, I mean, it's just because it was kind of like the further it goes, because we had a decision where, you know, we had an engineering plan approved in January, thinking there was going to be sludge holding tanks. So the aeration design proceeded with a setup of sludge holding being its own separate tank, and that changes the air supply mechanics to it, and type of diffusers, and even type of blowers. And so since we've already have blowers that are in aeration, a piping system in aeration, and diffusers in aeration, to go back to sludge holding tank, you know, we're talking that $150,000 change order. Or are we still the plan of building a sludge holding tank?
So we need at least one.
Yeah, we need one to meet today's flow, and we need two to meet the time traffic.
And
That's what it sounds like.
I distinctly recall, while I was standing there, budget
120
million.
million.
We need the sludge holding tanks. At one point where we reached the capacity that we had to do that, and we were told 10 years.
Well, that was, I mean, with that 10-year plan, we still need to do the change order of $120,000 to convert them
Right.
to Corsair, and then have a separate air supply for, on a PD blower for the levels that the digester can run. So-
And it takes $1 million, right?
Yeah.
One tank?
Yeah.
So you're talking 12% just on the change order, what it would take.
Yeah, I mean, for us to keep basically working as digesters, we need to do like $120,000 change order. And to finish out the plan and build the company, right?
It ain't working.
Right. And that's why, I mean, it makes sense to get the tank that we need to do for the long haul.
Next page.
You sold me on one.
The Fine Air.
If we go to Fine Air,
We're already going to Fine Air.
we already go with the change order, but we still
So where is the future? Well, it's efficiency. You're gonna get you're gonna see an electric bill is gonna be a lot lower than what we think it is. And that's kind of what's another driver.
We reversed that change order, correct? I mean,
Well, we never did change order. We're.
That's just what it would be if we do that.
Yes, like right now, you know, we had that presentation in April on, we have a value engineering amount of about 109,000 in credits. And then if we stick to keeping basin cylinders, digesters, there's a $100,000 cost that we didn't proceed with basically. So the only item that's pending as an increase would be the methane monitors, which we'll dive into on the 14th for the monofilm. And that's basically, the only additional item, you know, on top of the original contract and then issuing the separate contract and
See, I don't remember being told that we're gonna have Fine Air bubbles. Did you, Mr. Thomas?
I remember talking about Fine Air bubbles, but I didn't realize they would necessitate.
Correct.
they were gonna put us on a.
They were gonna put us on the bottom.
Right, and I didn't even know this until we were going through last week either, so.
This is an important workshop, and
It is?
I think it's important that Charles be on the recording on the mic when he speaks, okay? I hear you fine.
I'll stay closer.
but yet,
I'll grab a second mic.
We're going back, we're talking about things that happened in April, and we said, we missed that part.
Yeah, we did.
Where do we get in a box like this?
Right, and as I was preparing this workshop with Garver, I was surprised to find out the necessity of these sludge holding tanks. I thought it was more of a maintenance convenience. I didn't realize the seriousness of you know, the mechanics that are involved with Corsair, which is fine.
Yeah, how they relate to each other.
Well, why won't we have other engineers, why didn't they inform?
Well, I mean, we authorized them to do the engineering.
Go ahead.
And then, I mean, at the end of it, like, our current, the reason why we're in a funding problem right now is that the contract that we awarded came in roughly $2 million over budget. It was a $7 million estimate that came in at $8.9 million. And so now, yeah, and that's why we're in this problem.
But all the ones they picked come under budget.
That's right.
All right, let's roll.
So here's, the second slide is just more drivers. I know we get TCQ as the main one, but there are obviously some operation and maintenance drivers for streamlining the decanting operation. Your operators have to go out there with a sump pump.
Explain decant. I had a question mark there. What is decanting?
So decanting is removing the top layer of suspended liquid to enhance the thickening process, in other words. Sludge holding tanks by design have decanting facilities built into them to thicken your sludge.
Yeah, and you have to dry your sludge to get your...
apologize.
But write the stuff at the bottom of the bottle, and then, write it.
Yes, sir.
Right.
So, you know, obviously, again, operation and maintenance drivers, the decanting, and then your overloading of your drying beds. You want to be able to thicken before you send it to your drying beds, if not, you're chasing your tail. Solids loading and handling drivers, your current solids loading at the plant is at half of the rated capacity, 1.1 MGD. One sludge holding tank, not additional, one sludge holding tank will provide a 5-day holding at the current loading. And then the redundancy drivers, 2 of them will allow any one tank to be taken down for maintenance while maintaining that 5-day loading. And the second SHT can be constructed in the future when plant loading increases as you continue to take on more demand.
Still have a total revenue on that, around $8.
Yeah, it's a 35-foot diameter. I don't know the height off the top of my head, but I mean, I can pull the spec. The volume's in there.
Now, we don't know how it's going to be constructed or constructed of wire or anything.
Well, yeah, it's a concrete steel cylinder. Well, yeah, I look at the spec, and but I mean, that was kind of the value engineering was trying to get, because right now I think the foundation design is put in the middle phase by the contractor, which is probably the most expensive foundation that it would be. So there's a way to go ahead and get that cheaper.
You want to ask if he's still there?
Jeff, you still there?
Yes, I'm still here.
Okay, good.
Oh, hey, do you want to maybe elaborate on what these, what kind of value aspects we could add to the sludge holding tanks, or what kind of tanks would typically be put out there?
That's actually the next slide.
Oh, okay.
So Garver task revisited. We had presented that to the board at the last board meeting. I think that was task number 1. And so essentially what we wanted to do is just identify any potential process improvement opportunities and identify any cost-saving opportunities. Charles brought this to our attention. We thought maybe we could realize some potential savings. That was the only reason or justification for that.
Under
that
value engineering.
Yes, sir.
Okay.
Correct.
All right.
Correct.
That's what task for.
Yeah, try to trim some of this somehow. Alrighty. So Isla Blanca wastewater treatment plant. Just a quick overview. You don't have any existing headworks. We're hoping to address that. Y'all have determined that there are needs for headworks, and we also need to determine a design level of effort, obviously some costs, as an unfunded project for the November bond election. In addition to that, we're going to examine aeration basin hydraulics, which have been, we've been informed that that's an issue at that plant as well. And at this time, I'll hand it over to Jeff. Jeff, can you still hear me?
Yes.
So-
Can everyone hear me as well?
Yes.
Yes. All right, so thank you for the opportunity to talk with you all tonight. If we go to the next slide, we will see an overview of the Isla Blanca wastewater treatment plant. And our intent with one of our tasks is to develop a desktop hydraulic model of the aeration basins. So the call out on the screen says that we're going to identify hydraulic constraints and solutions. And if we're looking at that aeration basin configuration there, what we know from your operators right now is that there's short-circuiting in those basins, that flow is not necessarily proceeding in a plug flow pattern. The way that flow is collected out of the ends of those basins is problematic, and we know that we have lost capacity. Your operations staff have identified that there's lost capacity in those aeration basins, and that we can regain that capacity with some improvements to how the activated sludge, the wastewater in the end of those basins, is collected and sent to the secondary clarifiers. Now, previous studies have identified a method to do that with computational fluid dynamics. We've identified a method that takes significantly less effort, which we approved at the last board meeting for us to do a desktop hydraulic model. And we will complete that model, and after we've done that, we will identify the appropriate way to baffle the individual basins and reroute the sludge piping. And the goal will be to add or to regain capacity that's lost during peak flow conditions right now.
Question? I have a question. Question actually to Mark back there. Everything you're hearing sounds legit, right?
Yes, sir.
Well, those are the issues you're having over there. Okay.
Yeah, and with this rehab work, we've been able to take these spaces offline, and it's just fascinating how some of that, or confusing how those all of them and notches were put in place.
He's on the water side. Oh, okay. Thank you, Noe. Keep going.
Go.
Alright, so on the next slide, we have an overview of the improvements that we're going to be evaluating at the Andy Bowie wastewater treatment plant. This is similar, and some of this is going to be, I'm going to talk about, also applies, of course, to Isla Blanca. So at the Andy Bowie wastewater treatment plant right now, there's not an existing headworks facility either, and we need to identify those headwork units. We need to determine what the cost and level of effort for the headworks there is going to be. When we're talking about headworks scheme, we're talking about influent screening to remove large rats and debris, and we're talking about primarily in these cases grit removal, being able to move grit from the facility, which is sand and eggshells and other minerals. Specific to Andy Bowie, we're also going to dive into the energy efficiencies and potential improvements to assist the operational efficiency, and all of that will be wrapped up into the bond report. And now I'm going to talk more about those potential headworks and grit challenges that apply to both Andy Bowie and Isla Blanca.
Jeff, I got Jeff. No, I got another one more question before you get into that. You're doing a desktop model for Isla Blanca, but we're not doing a desktop model for Andy Bowie.
That's correct. The model that we're using for Isla Blanca is going to be a hydraulic model to identify how flow moves through the aeration basins.
And we're not having that problem at Andy Bowie? No.
It hasn't been brought to our
Okay.
attention.
No.
Yes, sir.
The outfall,
We're good at Andy Bowie. Okay. Thank you.
Yes, sir. So if we go to the next slide, I'll discuss the energy consumption evaluation that we're going to be doing at Andy Bowie. We are going to perform an energy consumption evaluation, but that's tied to a known challenge with headers. So if we're looking at this overview of Andy Bowie right now, we know that existing blowers serve both the sludge holding banks / aerobic digesters as well as the aeration basins, like the large rectangular basins there on the screen. And that creates a significant challenge for those blowers because the water surface elevation in those holding tanks versus the activated sludge basin is different. And therefore, the amount of air being supplied and how that blower operates on its curve is very different among those two basins. And it can't handle that efficiently. So we're going to look at separating those pressure planes so that we're operating the activated sludge aeration basin process separately from the sludge holding tank aerobic digester process. And that's a necessary thing for process control, but it will also allow us to see some energy optimization improvements because we're going to decouple this process, and the blowers that will be serving each one will be optimized for the specific tank it's serving. While we are conducting that process, we'll also evaluate if there's any potential savings to be had in replacing the diffusers with more energy efficient, potentially fine bubble diffusers, which would allow a potential savings from a business case perspective over time due to energy reduction.
But then we would need sludge holding tanks, right?
No, not in this case, because
No?
we're going to keep the Corsair from day one without
Okay. All right.
And then one of we do have rehab needs on our existing air supply pipes that we're not addressing in our current contract because we're not keeping those things offline. And rather than start diving into broken diffusers and headers that we need to fix their supports, we're just going to wait till this analysis so we have a good understanding of what
Okay.
Thank you, Charles. If we proceed to the next slide, it states that we will evaluate the need for headworks improvements actual wastewater treatment plants. Now, this is specific to Pandy Bowie and Isla Blanca. It should be noted you're currently under construction of a headworks facility at Port Isabel. So what you see on the screen in front of you is a 3D representation of a headworks structure for a similar wastewater treatment plant. And if you, Richard, if you advance so that the two boxes pop up, the two main things we're going to be looking at is the first one on the left, screening technology selection. So you'll see in this 3D schematic two screens which are going down into channels which the wastewater is flowing through. And these screens are necessary, of course, to remove rags and large debris that foul up downstream processes. And so we're going to be evaluating the most appropriate screening technology to remove the ragging that we see at that facility and do it efficiently to reduce operator and maintenance time associated with dealing with those rags downstream. So we're going to do that evaluation as part of the task that you've already approved. We're also going to be looking at redundancy, meeting PCT requirements for redundancy, and having some reliability in that screening process. The next thing we're going to be looking at, the third pop-up on the right-hand side, is right-sized grit removal. Now, this was very important, and I'm going to go into more detail about grit removal and how we make it right-sized. And really my take-home message to the board here is that right-sized means that we do the amount of grit removal that we need to do to help the facility, but do not spend more on capital for grit removal than we need to. I'm going to explain what that means. Any questions on the next slide? Okay. So on the next slide, it states that we're all familiar with challenges of grit within our wastewater treatment plant. These are photos of grit that's being removed. The grit is essentially inorganic that cannot be treated in our aeration basin process. This is rocks, including and eggshells, debris that gets into our system from storm events and infiltration. And so grit we need to remove early on in the process because it significantly impacts the operation of our facility. It can build up in our activated sludge basins because it settles out in the diffused air process, and that takes away capacity in our activated sludge. So we have to remove it because of that. It also causes wear and tear on all of our solids handling facilities. It tears up the pump, it tears up our sludge processes, and it fills up our holding tanks. So we need to remove grit. We currently do not have any grit removal processes at Indy or Isla Blanca. If we go to the next slide, I'll present to you this concept that in our industry, no one can agree on what type of grit we actually need to remove. I'm presenting this because I think that we have a very unique approach to how we are suggesting to go about doing grit removal. On the screen, you'll see a graph, and really what you're looking at, if you look at the vertical left-hand axis, you're looking at diameter and microns, so it's size of the grit particle, and you'll see a general representation across the screen. Small gravel that comes into the plant is about 850 microns in diameter, down to fine sand and beach sand. If you advance the slide, it'll then state that historically, best available technology determines grit removal efficiency. Meaning, if you decided as a board that you wanted to install grit removal because it will greatly enhance your facility, that in doing so, you would essentially in the past, you'd go to a manufacturer and you would say, providing a grit removal package, and Richard, if you advance the slide, I'm showing you here that those grit removal packages in the previous history, on average, would remove 85% of particles that are around 180 microns or larger. And Richard, if you advance again, those facilities would remove 65% of particles 150% or larger. So in the past, with old technology, we could not remove all the grit. Now, if you advance one more time, I'm going to tell you that now there's technology available that can achieve removal of just about everything. The manufacturers will claim that we can remove 95% of all grit 70 microns and larger. And there's been a really big push by consultants and utilities, and that's not a bad thing, to install this type of technology where we remove all the grit that comes into the facility. But we have to ask the question, is that really what we want to do? Now, if you advance to the next slide, I'm showing you a stack tray system. And stack trays can remove the finest grit, but are also the most expensive. So your grit facility you're building right now at Fort Isabel is what we call a stack tray head cell system. It is the technology that's available that can remove just about every type of grit particle that's out there. But the challenge is that while it can remove fine grit, when you get advanced technologies, you also deal with some significant disadvantages. Higher head loss is the most expensive grit option that's out there. It can be a known nightmare. These systems do not do a very good job of handling first flush events, which is the beginning of a large storm where we get our feet closed. There's issues with these things plugging. Lots of grease can cause challenges, and they're sole source. Now, I'm not suggesting that these are bad systems. These are fantastic systems if we need to remove the finest grit particle that exists.
What does that mean, high head? What does that mean, high head loss?
High head loss means that that is the amount of elevation you need of water entering the grit chambers and exiting. And what that means is that if we're trying to put this into an existing facility, that could change how water flows through an existing wastewater treatment plant, because we have to account for the loss of energy and for the head loss going through that system. So in a retrofit application, that can mean that we need to install larger pumps ahead of it to account for that. It's just something we have to consider in design. Does that make sense?
Yes, it did, yeah. Thank you.
So I'm not knocking the UTEC head cell system. You're getting one of these installed right now. They're fantastic systems. But what I am suggesting, if we go to the next slide, is that there exists a trade-off on the cost of grit removal. So what I'm presenting to you here on the x-axis is a general representation of micron size. The left-hand side is 300 microns. So if you think about a micron, that's the diameter of the particle. So 300 microns would be a larger particle than 50 microns. 50 microns would be like silt, and 300 microns would be like sand. Okay? And the left-hand axis represents capital cost of grit equipment. So Richard, if you advance the slide, you'll see a line pop up that says, old tried and true conventional proven processes are lower cost. That's why the dot's much lower. That's a lower capital cost, but are really only good at removing those large particles. Or we can install brand new technologies, like the stack tray system I just showed you, that can remove almost everything, but they're much more expensive. They're more expensive to build and more expensive to maintain. So and that's where our industry's gone. Our industry's gone with, if you need grit removal, let's install the best technology we can, and let's move forward with that. That's what our industry's done traditionally. What I'm suggesting, if you advance the slide, Richard, is that we really need to identify what the cost is. So what you're seeing now is the right-hand axis represents our downstream O&M cost, meaning after our grit facilities, how is grit really impacting that facility? How much is it costing? Is it impacting our activated flotation? Is it destroying pumps? Is it destroying our solids process? And we know that large particles cause max wear and tear and reduce our volume, and that smaller particles cause less of a downstream challenge. And that somewhere in the middle, unique to each facility, is an actual grit particle that's causing problems. And so what I'm suggesting, and what we're going to do for y'all, through a pretty simple evaluation process, is to identify what that grit particle size is, and design around it, so that we're right-sizing the grit facility and not just installing what is known as the best technology, but the technology that's the right size for each of your facilities. If we go to the next slide, I represent that we must understand the four components of a grid system. Now, we're gonna dive a little bit more technical here, and I'll move through this unless you have any questions, any detailed questions. But essentially what I'm trying to represent here on this page is that a GRIP facility, almost everyone talks about the basin where the majority of the wastewater flow goes into. But a GRIP facility actually has these other components that are often not engineered. They're just part of a package that a manufacturer provides. And that includes a pump to pump grit out of the basin, which sends it to a hydrocyclone, which concentrates and removes water, and then sends it to a classifier unit, which is basically it's a screw auger that takes the grit and dewaters it and puts it into a dumpster. And if you advance the slide, Richard, I represent that 3 of those 4 components have overflows that do not allow us to put grit in the dumpster. Now, the reason I'm spending time talking about this, board, is because this is a unique approach we have that I think we can right-size these facilities, and essentially what I'm telling you is that I think we can spend less capital money to design you the correct type of grit facility.
Right, and just to give you an idea of what kind of dollars we could be looking at saving, I mean, right now, if you go to the schedule of values for the headworks at Fortisville, it's approaching, well, like it's at 2.9 million plus delays we have to figure out for all these drill crews. So, you know, that's the kind of item we're looking at that's major. So the more we can identify on, you know, right sizing it, I mean, you can kind of see the difference.
Can you pay for our sludge holding tank?
Oh, well, we'd have to get the, I mean, we're sort of.
That's the
Well,
goal.
that's how it's in
That's the goal.
We usually let that.
I understand. Hey, Mike?
So the next slide represents the process we're going to be doing over the next 2 months. This is a small task, a small financial task that you approved at the previous meeting for us to do this evaluation to identify the right size grid facility. And this is our approach to right sizing grid facilities. The 5-step approach, I'm going to go over a couple of these steps. The first one is that we're going to actually identify the cost of impact of grading the facility. We know grit's impacting the facility, but we're going to identify what that is. We're going to identify the grit challenge areas and sample them. Item 3, we're going to identify the target grit size. We're going to compare that target to existing. And then step 5, we're going to determine a cost-effective solution, which we'll recommend in your bond report. If we go to the next slide, so step 1 is to determine the cost of grit at the facility. And this is a pretty simple task. We're going to be working with your operations staff to take sludge samples out of the bottom of the activated sludge process, your holding tanks, and your aerobic digesters. And Richard, if you advance the slide, we'll be able to, working with your operations staff, calculate the cost that grit's in, how much cost grit's impacting the facility. Are we changing our pumps and rotors and stators faster than what manufacturers recommend? Are we cleaning out basins more than we should be? We're going to add all that up and be able to state with some degree of confidence how much grit is impacting the facility. We move to the next slide. We'll evaluate your grit challenges through some sampling protocols. We have some unique sampling protocols. You'll see in the slide there some of the equipment we can use to grab samples pretty easily. And then we'll evaluate those samples on site, like we are in that photo on the right, that's leading with grit analysis at another facility.
We'll also use that.
Step 3, I'm sorry?
Now let's just mention like the oven, for example, we already have it here at our lab, so we'll be using some of that equipment in some of the testing.
Well, on the next slide, step 3 is we'll identify the target grit size to remove. Richard, if you'll advance that slide 3 times, we'll have 3 boxes pop up, and what I'm indicating here on the schematic is that we can go to these basins where we know we have a grit problem, like an aeration basin or a thickener or an aerobic digester. We know grit size out of those basins, that's where it's causing problems. We're going to develop a really easy sampling protocol. It's low cost, where we grab samples going into the basin, we grab samples going out of the basin, and we try to collect some stuff off the bottom of the basin. And then with those samples, we can identify the size of particle that's causing the problem. This is a very simple way to say that we're actually going to design around what's causing problems in your facility. The next slide is a representation of our grid business space tool. And so this is a screenshot of the tool we developed where we actually developed this tool for the city of Houston to evaluate their 44 wastewater treatment plants from grid meters. What's the most cost-effective option? So we can utilize this tool to build Isla Blanca and Andy Louie quickly in the spreadsheet, and this helps us calculate a cost of grid. And so in the end, if you advance to the next slide, Richard, the end result that matters most to you all is that this helps us prepare alternatives to identify a most cost-effective solution. This is an example output of the tool for one of the Houston facilities, and it will help us identify a do-nothing option, which is called basin clean, where let's say we don't even do grid. We just know that it's going to cost us money over time, and we've got to take our plant down, and we have to remove it. We're going to have a life cycle cost for that, versus a life cycle cost for installing grid systems. Now, these costs of this example, this is a much larger facility, so these costs are not applicable to this facility. This is just for sample output, but it will tell us what type of grid system among many options. I showed Vortex Grid in the field, but we'll look at other alternatives. The screening tool will allow us to quickly screen and say, you know what, your best option is this type of grid meter. And that's what we will then recommend and document and put into your bond report for you to review to determine if that's how you want to move forward. But our business case will be built around the life cycle cost of what it's going to take to build a grid facility to reduce O&M over a 20-year period and help optimize the facility. So that's our goal with this task. Any questions?
I like what I'm hearing so far.
Yes, sir.
Thanks, Jeff. And just so y'all know...
I think we turn it back over to you, and I'll be standing by.
Thanks, Jeff. I appreciate it.
Thank you for your time, Jeff.
Just so y'all know, Jeff Sober is a physical separation treatment expert and a biosolids expert. So if y'all ever want a 6-hour crash course on grid, we can give him a call. He could be here all day talking about this. This is his game. So thank you, Jeff. So the next item is system-wide lift station rehabilitation. If we can go to the next slide. So just a quick recap. Your staff has identified this as a need. It's supported by previous reports. Current system-wide evaluation is needed, and obviously some level of design effort and costs are needed to include into the bond report. We go to the next slide. We've got a little more detail. So over $700,000 of pump replacement needs have been identified as of March of this year. In addition to that, as y'all know, in your collection system and dealing with lift stations, improvements needs are ever-changing. You've got pumps that go out on Sundays, it sounds like, here over the past couple months, but they're always going out. There's always a need, so that's part of the justification. Again, it's supported by previous reports. Your 2012 wastewater model.
Same with the pumps. You're going to be working on that problem that you were speaking about, that our pumps going out, etc. Will you be giving some recommendations on the best pump for our needs?
Absolutely. Yes, sir. And it seems like the controls, I think, are more the issue at this point, right? There's electronic issues or electric issues with your controls that don't, I guess, bypass the fail-safes that are normally equipped with a lift station. And so if that fail-safe isn't working and your pumps overheat because it rained, they just go out.
And we also need to make sure the pumps are operating on the correct curve, or they're set up for the right condition.
Exactly.
And we have the right pumps.
Right.
Yes, sir.
So that's changing, I'm assuming, all the time. So there's something that are out there that I'm most interested in.
Absolutely. Yes, sir.
And one thing we also had an issue with in the past has been, well, we had brand X in this lift station, we had brand Y in this lift station, and if we ever needed, it'd be nice just to have all these pumps the same brand.
Yes, sir.
And that way we can have maybe an extra couple sitting around the warehouse ready to jump in.
Yes, sir. Absolutely. In addition to that, this project is supported by previous reports. 2012, y'all had a wastewater model completed. Your systems were analyzed and evaluated then. Recent efforts also have included lift station evaluations and improvements recommendations. But again, a system-wide evaluation is needed. That was done, but it was done in 2012. In addition to that, the wet weather flows that were indicated in the report, we need to calibrate those and see if there are some cost savings there as well. We'd like to get as conservative as possible on those and actually set up some flow monitoring to calibrate your model and determine whether or not that size of infrastructure is really needed.
Yeah, so you don't overbuild.
Exactly. Yes, sir. Cost determination, obviously that's a big thing. Since these are unfunded projects, we'd like to move through this, get some costs and level of design efforts so we can include in the bond report. That's the ultimate goal. Next slide. Lift Station 11 force main upgrade. Recap, project recommended by a previous report. The capacity gained by upgrading this force main has a direct impact to Port Isabel Wastewater Treatment Plant. There are already provisions underway for a force main upgrade, and again, this is something we'd like to include in the bond report. If we go to the next slide, we can go into a little more detail. Yes, sir?
What is that?
It's the one recommended warehouse. It's the master lift station for Port Isabel. So basically, just upgrading the force main will get us that peak flow 4 versus our limiting factor for the peak flow 2 plant, eventually the recycling plant.
Yep, so this just reiterates what Charles just said. You've already had an analysis performed that's identified 6-inch diameter as an optimum selection. Those proposed improvements are obviously empirically supported, and then your capacity gained has a direct impact to PI wastewater treatment plants. It's the influent lift station. Firm capacity of 4.4 MGD would be realized with the upsizing. And you've got provisions currently underway, I believe, inside the fence at Lift Station 11. You're already upgrading all of the valving and piping to 16-inch. Now it's just a matter of continuing that to the wastewater treatment plant.
Where's lift station?
Right there on the corner of Waste Lane by the warehouse.
And then obviously inclusion in the bond report for design and construction. Next project is a water reclamation facility. Quick recap on that. Substantial work has been performed on this project to date, and there are considerable water supply drivers. This water source is supported by previous reports by others. The treatment method is supported by previous reports. There are cost drivers, and obviously this is part of your Region M water plan as a recommended water management strategy. The next slide has a little more detail. So you've already had an evaluation, analysis, and recommendations for an alternative water source for advanced treatment. There are water supply drivers as well. I think there is a deficit, or a deficit has been identified, right, Charles?
Yeah, under fully prorated condition, we're using more water than we're allocated for.
Correct. So, and I think that needs to be balanced by 2020. That's what I have in there. Yes, sir. Exactly. This is a supported water source. Reclaimed water for LMWD has been currently identified as the most feasible alternative water source for additional supply. So in addition to the water source, the treatment method that's been identified is also obviously supported by analysis and evaluation. The proposed advanced water treatment design for DPR has been identified as the most cost-effective of all considered, including the indirect, desal, etc. And this project is supported by your state water plan. If we go on to the next slide, you can see on the 2017 state water plan list of recommended projects, there's a brackish groundwater desal plant, which I believe was a partnership with Southmost.
That's Southmost Regional Water Authority.
Right.
It would be a 12-mile pipeline, and then we have to buy into the treatment plant over there.
And so that's the identified cost to date. The potable reuse is at 13.6.
And now that 13.6 includes a portion of work that's already under construction.
Correct.
So out of this 13.6, we're already building 5-6 million of it. And that's kind of where we end up with the numbers.
Yep.
When you apply the volume of the capacity between the two, between groundwater itself and wastewater, volume reuse,
The next slide has some acre feet that have been identified in the plan.
Well, I mean, and
But-
as far as, like, we're basically, right now, we're a silent partner with SRWA, so we buy the
That line,
the diameter line.
if they were coming from the Brownsville.
Oh, I don't know the diameter. I know back in the day, there was, I don't even remember what line size they were talking about.
Seemed like a 24 inch, Charles, 24.
Yeah.
Yeah, 24 inch.
Yeah, but at this stage, you know, we know we're a silent partner, I mean, we'd have to buy it from scratch.
One thing that's not on this slide page is us taking that $5 or $6 million and buying $5 or $6 million worth of water. Yeah.
Well, yeah, I mean, that kind of comes into our rate structure and the revenue source, because the way our rates are built is the only time any money is allocated to water rights is at the time of annexation. So essentially,
I think Texas is gonna switch to the user basis also. That's another topic.
yeah, I mean, really, our revenue structure doesn't have any source that builds any balance in our water rates, on our water revenue. Basically, it's really for areas that haven't been annexed, we should be requiring them to buy in, but then we're already at a condition where our existing district boundary doesn't have enough, or has a demand that's higher than the supply, and it's just gonna keep increasing.
Oh, no, I'm just trying to put out there, I'm just trying to put out there that anytime water rights pop up, we ought to be jumping on them, to be honest with you, in my opinion.
Well, we could put some bond money up for that.
Is that, that would be a legal question, I don't think.
That's a good question right there, because
Good question.
Yeah, I don't know about council, but.
I don't see why it wouldn't be.
Yep. Let's find out.
Well, if we're looking at the next page, and I'm looking at the previous page, I'm looking at, you know, the cost projected, the carbon we use versus the Brownsville plant.
Well,
My point is, I look at the next page, so I'm seeing that the Brownsville plant produces 3 times the amount of capacity that we could get for the thing, for the buck. And then, but yet, you know, the cost of our reuse is more than half.
well, if we scroll to the next slide, I mean, those are numbers straight out of the state water plan. So Black and Beach is the one who came up with this, with these, 285 versus 780. But, I mean, just today, January through April 2017, at 75% recovery, which is what we would expect, we would have already recycled 193 acres. So in reality, based on our existing flows, we're looking more at being 660 acres. That this is just really a number from the state water plan, that's lower than what would really be produced with our current flow.
All I was doing was simple math, looking
Yeah.
at what it costs us to be there, and if we're gonna spend the money on a reuse plan, you know, what's it gonna cost us per gallon or acre foot?
But
Yes,
just
sir.
simply, yeah, but with our existing flow coming into PI and accounting for loss with the desalination portion of it, I mean, today, with that flow coming in, and then back, we'd be running about 650 acres. That's where we're at with our current flow.
If I may add here, team, you're absolutely right on the capital cost, not matching up the capacity. One thing that I think, we're in a planning stage right now, moving forward, looking at your water supply options, we need to be thinking about them on a life cycle cost basis and comparing what's the operations and maintenance cost of a desal facility versus a reuse facility. What are the permitting costs and the disposal costs of our brine? And we need to factor that in, because that could greatly tip the scale one way or the other when we look at those overall long-term operating and disposal costs as well.
That was gonna be one of my things I brought up today, is if we do go with potable reuse, what's it gonna do to our operating costs? And that, to me, that's the key. What's that gonna do with our water? How much not we're charging, but how much it's costing us to do 1,000 gallons? What's that gonna do to it?
Yeah, from the feasibility study that was completed for information, I mean, our cost of production today with our MF plant is about $1.50 per 1,000 gallons. And when you add the direct flow reuse, that 12% is gonna be an additional $2.25. So it's only 12% of what you're just mixing in with the river. So you just kind of break it down, and like the rate study that economist.com has done, where there's that spike in the 2019 rates, I mean, I think we actually already had that figure that not really accounted for the O&M like that, for the local use of the asset.
What about the fact that we have the 3 water plants, or we have wastewater plants that are so spread out, we're not gonna pack them all together, are we?
Well, no, I mean, all this is,
Just gonna be using one plant.
this is strictly according to building.
Right.
And what we can do is we can route one, like we can route, say, even the first lift station at Laguna Beach, then route it through Laguna Heights back to the plant, back according to building. But the pipes are in place to keep expanding in that manner we should.
But the logical question was brought up, what about buying more water rights, just to plan for the future needs? We're talking about reclaiming 12% or mixing 12% of the existing water to meet the needs. And so, break it down to some dollars, per acre foot or 1,000 gallons, whatever you want to do, to where we can wrap our heads around this, because
What will Brownsville sell us water for?
Oh, we'd have to negotiate. They do have water rights. Yeah.
I don't know if they'd sell us in the water, who knows? The way Brownsville's been expanding.
Off of their,
Well, we could enter a lease agreement. There's ways.
Their agreements are getting back.
we were talking about that supposedly water line coming 16 miles from their,
Well, they've also done a lot of,
Rural plant.
they purchased a lot of water rights from Cameron County Irrigation District State. So I think they have room to be able to enter into lease agreements.
That's what I was gonna bring up next, right, these districts, are they still in business?
Who's that?
District six?
Yeah.
You said they had excess, but Brownsville ended up buying all that excess?
Well, yeah, I don't know the details, but I know they did purchase.
We missed out on
It,
Yeah, I wouldn't even know.
I'm not defending your saying.
I'm just saying, we knew there was an excess, I think even when Mr. Sotelo was down on it, I think that's when I heard about District Six. Maybe we should have been a little proactive and try to jump on that.
I still think on the water rights thing, that we need to be working with the wildlife refuge. Wildlife refuge, get a federal grant, and build a reservoir. We'll fill it up for them with their water. And we can use it anytime we want it, because there's so many times that we can pump continually.
Yeah, we've done it, I think, once this past month. No charge, 3 times, yeah.
All the grease people that use their hydrant system.
All that land in between 5, 10, and 100 now is U.S. Fish, pretty much U.S. Fish and Wildlife.
Yep. 500 acres.
absolutely.
Very good for us. And they've already got 1,000 acres of water rights.
Yeah.
They got our 10 acres.
And with the
Yeah, that's right.
wildlife
Hmm.
There's getting some of our politicians with real feathers in their hats for sponsoring this deal. Because all the green people would love it. Got unlimited
Is it too late to figure out something like that?
Well, I mean, we have 2 months to do the analysis. I don't know if we can do an estimate for water rights
They'll build the
analysis.
reservoir.
We'd love to look at it.
Yeah, it would be, it's not in scope, but we could add to the
Yeah, first thing you have to do is factor in the evaporation rate to see what your storage will be. If you're talking about storage, you're just 3 times, you're going to 3 pumping size.
We keep it full all the time.
No, I would think like El Dorado.
Keeping their water rights.
Yeah. We got that one looking by the river, watching this, and over this one, and how the water would flow, right? Another one. And watching here.
You have a pump station right there, and you pull out of the same way we're doing, we're flowing in from the river into our 160, whatever acre feet, right? All right, right. Okay. So we're flowing out of that to the plant. Do the same thing. You got a 24-inch raw water line walking right by this.
Yep, right exactly at the 10 acres.
10 acres, that's
Mhm.
the line.
Yeah.
Take a 3 valve.
So, this is Jeff, if it's appropriate for me to speak up at this time, I would suggest that, one of the things we've been talking with Charles about is water supply, portfolio diversification. looking to identify what their water supply options are, and making sure that we identify the least cost option, so that we can better make a decision on whether to invest money in a reuse facility, desal facility. We have a tool, a screening tool that we've developed, we call it a source of path tool, but SC squared, that can look at your water supply options, looking through the Region M water plan, and identifying what the options are, then plugging that into this tool, and it'll identify the risk with each option and a cost, a capital cost and a life cycle cost, to help you identify what might be the least cost option moving forward. And that can be as simple as groundwater supplies, reuse, desal, ASR, additional water rights purchasing.
Building a new reservoir, maybe, and taking advantage of the pumping that could be put in there.
Well, I mean, if we could do the analysis on it based on the North End Island, that would be an option.
One of the things we were going to look at on the previous task one that we proposed that wasn't authorized was that currently the costs developed for the reuse facility are based on full advanced treatment, and we've done a lot of research on potentially decreasing those costs through different technology selections. That's one of the things we were going to revisit in that task one, if we could potentially reduce those costs through an optimized technology selection. So I think there's a lot of options out there. Looking at, we know that we need to identify additional water supplies. And I think we can help you do that through a screening method that looks at the risk of those water supplies and develops a cost estimate to bring for. And that it might be more prudent to have that discussion with a baseline screening analysis completed first.
Is that something you want to see as a follow-up work order?
Well, that's a good question.
What does that entail? What is that?
It wouldn't hurt if they came back to us with something.
I always
Right.
did one, just kind of expanded along the conversation we had tonight.
Well, I think before we start paying engineers, find out, let's go out there and talk to the wildlife people first and see if they're even interested in it. Mr. Chairman of the board.
Mr. General Manager of the board.
We can? Yes, we can.
I'll go with you.
Certainly, we already have numbers to call.
Not a bad idea. I'll go with you.
The question is how much federal funding they build on. That's the big buck.
Trump's got money everywhere.
Oh, yeah. He's got his stamp. You might want to put a hotel out
Alrighty. So next slide was just going over the current recommended plan. I think y'all have already seen this. Moving to the next slide. Water treatment plant 2 sludge drying beds. Again, this is something that's been previously analyzed, identified by your staff as a need. There are cost drivers, solids loading and handling drivers, and we're hoping to provide provisions for a complete system and include that in the bond report as well. Next slide has a little more detail. So the evaluation and analysis and cost evaluation that was previously performed recommends the use of sludge drying beds at water treatment plant number 2. Due to the existing sludge pond being ineffective at producing solids, and the existing sludge pond is difficult to clean and maintain. It's essentially full currently and has been full for a while. In addition to that, there are cost drivers that have been identified as sludge drying beds being the most cost-effective alternative. Solids loading and handling drivers. The current system was not designed for an MF plant or MF treatment type wastes. So that's something we're going to look at with the MF addition. The proposed Garber task that we'll be submitting for the next board meeting will have provisions for the entire system.
Yeah, and this is, I mean, you know, as far as giving status of the closing for the plant, we do have that board resolution authorizing the sale on June 14th, and so I mean, we'll be closing on the land purchase, you know, shortly thereafter on the meeting of the 14th. So I guess the question is, you know, we've already budgeted the engineering effort, you know, with that last amendment. So I mean, if you'd be okay with presenting the you know, kind of revisiting that authorization that was Garber on board to proceed with final design for those new sludge holding tanks and whatnot.
Sludge drying beds.
Oh, sludge drying
Not
beds.
holding tanks.
No, not holding tanks, sludge drying beds. And I mean, the other part of it, well, I don't know, we can dive into it. Yeah, I guess half of it.
Yes, sir.
I'm curious to how much money they spent for all those phosphorus crossings between here and...
27 million is what they're saying.
Is that about gonna be
27,
27 million?
24 to
I'll bet we
27
can
million on
build a
everything.
big reservoir for 27.
The overpasses, the fencing, that's what I heard, 24 to 27 million.
And did it all come from TxDOT, or was a
It
lot
all
of it
came from you, that's federal money.
USDA, federal one? Federal
Federal.
fund. All of it federal fund.
Federal fund.
Well, they need a lake for them devils to drink out of, too.
There you go.
You put enough habitat
Bring the leopard back.
on that, they may not be traveling as far as they're traveling.
And what they're really trying to do is reduce it, they really need to reduce the salinity in Bahia Grande. And like from El Salvador, they're trying to figure out how to get water down south 100 and reduce the salinity levels. Because the wind just comes and goes in and it dries out, and it's an exponential increase in salt. And so they need to find a method to reduce that. Yeah.
And you guys, I think you start talking.
Yeah, but not there. We don't want salt in the water.
But I mean, it's just one of those things to where if we dive into that level of detail.
They have a problem that we can work with them on.
Yeah, yeah.
Well, we know they're gonna, eventually, Bahia Grande is gonna sell it. They wanna reduce the salinity of it?
Yeah, it has no ICD that, you know,
They're closer to Brownsville for that. Well, if they
we're
try to
actually
do
not
that
too far.
brackish thing.
Well, we're not too far from 100 to where the Bahia Grande is.
Close by, dump our raw water line in there.
Just keep moving, please.
All right, so the last driver, since this would be an unfunded project, is inclusion in the bond report. So the last two items are just updates. Water treatment plant number 1, hydraulics, and a filter study was identified by your staff as a need. A small study was completed, and just wanted to bring y'all up to speed on the findings.
Yeah, and basically, to kind of make, sort of, while we're including these, is the fact that we did look at the needs at water plant 1, and don't see any, you know, need for a bond project, just because the improvements are high cost dollars.
Yep. Yep.
So we'll spend it.
Yes, sir. Essentially, on the next slide, like Charles said, results were to be considered for the bond program. So this analysis included creating hydraulic profiles to determine that bottleneck that had been identified by your staff. Bottleneck was encountered, but it was encountered inside your clarifier, not in your piping or your filters. And what was determined is the existing orifices on your launders are incorrectly sized. So if you operate at a certain hydraulic grade line above those launders, you can run a theoretical calculation to determine how much flow each one of those is producing, times how many are on the launders, times how many launders for your clarifier production, right? And so we modeled that, determined that I think the most you could run through that clarifier was about 1.5 MGD when it's originally designed for 4. And I believe that's consistent with the output of the plant, correct? In combination of the big clarifier and the small clarifier. So if you take the holes from 1/2 inch diameter to 1 inch diameter and run that same model, you get exactly 4 MGD. So it's a pretty pretty inexpensive fix. It's something very simple, but that is where the bottleneck exists, is within your clarifier. We,
That essentially needs to be included in the bond.
Well, what's the cost of drilling?
And they're saying, no, that's not.
Yeah. No.
Yeah, these are things are not bond projects. We did analyze to see if there'd be major, capital required there, but there's,
It's just in this report, things that you do and identify.
well, plus we've done the study, you know,
Right.
here, so we're just getting the update.
right. There are recommendations, though, obviously. I have to go over this. Recoding of that clarifier, the internal steel components are in a pretty poor condition, so recommending a recoding. Reinstatement of the automated filter controls, I think there are some maintenance items necessary there. And then the study that was performed did not address any sort of water quality. I'd recommend going back through and identifying possibly if plate settlers or tube settlers are needed. But bottom line is water quality was not addressed
Yeah.
in the evaluation. It was simply hydraulic.
Right, at the end of the day, humidity must be what sets our limit, so we'll
Correct.
still gotta run that.
Correct. Yep. All right, next slide is the CT study update. Charles, you want this one?
Yeah, I mean, it's basically, you know how we already added chlorine dioxide to water plant 2, and our THMs are fantastic, they're coming at 20, 30 milligrams per liter when our limit's 80. You know, I don't, might be quite familiar. Oh, what, okay, yeah, so basically, you know, we've really resolved a long-term THM problem that we did have by adding the chlorine dioxide generators at, yes, at water plant 2. And so really, our existing CT, with you still on, with chlorine, still chlorine dioxide at water plant 1, and it actually limits even certain water temperatures. We have to reduce the capacity. We can't really run cold weather operations with our current data in place. We skip to the next slide.
Oh, yeah, sorry.
And so basically, yeah, but I mean, it's just one of these things to where we really do need a stronger disinfectant on there. You know, and plus we already have a manual generator at water plant 2. It's just one of those options where, you know.
You can take water temperature. I've been trapped, had people try to trap me on that, the conduit. Oh, there's something wrong with your pumps, because we got thermal relief valves on the pumps, right? So, well, why? Well, the water's too hot in the units, and so you go up and you turn the cold water on, you let it run for a while, and it's 88 degrees. Oh, yeah. You go down to the hose bib outside, it's not on the pump, it's 88 degrees. That's what the groundwater is, 88 degrees. Coming out of the ground.
I mean,
Our potable water.
yeah, I mean, because, well, the thing is that the water directly attempts the log removal of viruses, and that's really what the cold study is for. And so really, you know, each condition, I mean, technically you should be doing the calculations to know what concentration you need to use. And with chloramine, because they have such a long contact time versus chlorine dioxide, they have like that. That's really what triggers the limit on your capacity.
Quite a little bit on that one.
So that's kind of.
But the temperature, I'm telling you, the water temperature is rarely that cool.
Yeah, I agree. But I mean, I think there's still value, especially with a generator at one time that we just picked up and put it together just by saying from pilot. You know, we can have point out that both plans. That's basically, you know, just kind of an update on that one as far as what we're working on, taking a look at.
All right, that's the end of the presentation. Any questions?
You guys can get back with us on what we discussed about the water options? Y'all want me to?
I'm fine with that.
Get back with us on the
Yeah, we should include it in.
I'm fine with it.
Really look at it.
Yeah, I mean, I certainly like to look at it, we're taking the time to talk about reuse.
One more option.
And, you know, not just working with the feds, but then, you know, to find more water rights availability, figure out how we could do that.
Yeah, and I'll check with legal to see if water rights is, if we have the authority to put that into fund election report. I think it's a fund source, to buy water rights. So I'll see if we can do that.
How many do we buy about a year and a half ago? We bought 500?
No, we have to convert it to municipal, it was 76, 79 feet for about 150,000.
So,
That's Class A or Class B or?
That's how you converted to municipal. Class A, it was 150 acres, and then we converted to municipal.
Thank you everyone for being here tonight, a lot to consider, and let's make this progress move forward.
Thank you for having us.
I'll say that I appreciated the report that Jeff was giving, saying that they're gonna take each plant, gonna break it down, when they're listening to the Silver report, he's gonna take and analyze what it is, he's gonna break it down, and give us individual reports on that. I appreciate that.
Awesome.
Excellent.
All right, thank you.
Good night, everyone, thank you for taking the time to be here. You're all.
Thank you, Joe.
Thank you, Jeff.